Here is a small update on the Cobot design. If you watched the previous videos, this is the same Cobot that was originally designed around 6 identical motors, but after doing some basic torque calculations, I realized pretty quickly that the base needed to be a lot stronger. So, back to the drawing board. The new design now uses a much larger 5065 BLDC motor for the base. I'm still using the planetary gearbox from the previous design, followed by the cycloidal gearbox to give me a much higher overall reduction and hopefully more lifting capacity. I've also changed the arm layout. Motor number 3 is now mounted more towards the middle of the arm, while motor number 4 sits right on the edge of the elbow joint. The idea is to keep the first 4 axes as compact as possible and keep the heavier components closer to the base. The last 2 axes are the wrist, which are much simpler to package. And this is the 3D printed wrist assembly. It's still a prototype, but it's starting to look like an actual robot now. Also, I want to quickly mention a comment from Sierra Echo 884. That comment actually gave me the idea to try designing a pneumatic actuator. I initially wanted to make a vane-style actuator, but making one that works reliably with 3D printed parts turned out to be pretty difficult. So I designed a much simpler linear actuator instead, which is much easier to 3D print. But I don't think I'll be using it on this Cobot. To lift even around 3 kilograms with the geometry of this robot, I would probably need to move from pneumatic to hydraulic. That would make it extremely powerful, but also extremely impractical for a Cobot. So definitely not going on this robot, but still a really interesting experiment. And thanks again for the idea. If you would like to try it yourself, the design is on Colts 3D. Link provided in the description below with all the needed components. Now back to the Cobot. The main electronics will be mounted on the base, on the motor side, with the wiring running into the arm through a drag chain. I've got an ESP32, LCD screen, magnetic encoder, and an MKS Dual FOC controller. The FOC controller will drive 2 of the smaller 5010 BLDC motors, while the magnetic encoder provides the position feedback. The goal is to make these BLDC motors behave more like servo motors, with closed-loop position control. This smaller electronics assembly will then sit on the arm and control the 2 nearby motors. I've also left some space around motor number 3, which lifts the forearm. That's intentional because if I don't get enough torque from the current gearbox, I can add another reduction stage here later. So that's where the Cobot is at for this week's update. The design is getting closer, the electronics are starting to come together, and now I just need to turn all this CAD into actual parts and see if the calculations were right. Hopefully, the build goes well this weekend. As always, stay tuned, like, share, and subscribe. And until then, let's rotate.